Hey guys, today we're talking about properties of reflections. Here are your learning objectives. I can describe properties of congruent figures. I can draw a reflected image. I can draw lines of reflection. I can describe properties of reflections. So let's get started. I have a picture of a dog for you today. I love dogs. And I have my pre-image on the left, my line of reflection, and I'm going to draw my image on the right. So once again, to do a reflected image, we're going to put our transparent mirror, the recessed edge, along the line of reflection. We're going to look through the mirror at our eye level. Our mirror stays on the page. We don't pick it off the ground. And then we're going to look through it by tilting our heads and getting our eyes down towards the paper and drawing the image that you see. I'm going to flip over to my camera. I have a copy of it here, and I'm going to go ahead and get my mirror. And I have my recessed edge right there. I'm going to set it down. And so, of course, since my camera is facing straight down, if you were to look straight down at this, you would not be able to see the image. But I'm going to pretend, and I'm going to tilt it a little bit so you can see what's going on the other side. You can see his nose and his eyes appear, all right? So I'm going to pretend, let's pretend, that you are actually looking at this from the side and you're able to draw what you see. I'm going to go ahead and do it for you right now. All right, so I have my picture done. It's tricky. It's not easy, that's for sure. You have to have a steady hand when you do it. I'm going to take it off. It's pretty close. It looks like my line's a little bit closer to the left. Sometimes that could happen, but to be honest with you, my picture should be a little bit, or my image should be a little bit closer to the line, but we'll go with it for now. So let's go back over to our notebook and take a look at some things. Now, we talked before about how pre-image, with the word pre in pre-image, means first or before. So a way to remember the pre-image and then the reflected image is that the pre-image is what comes first. It's before the flipped image. And so I want to talk a little bit about how our drawings are alike and similar, or alike and different. So let's switch back over to our camera. And we're going to do a thinking map, because we like thinking maps. And we're going to talk about the differences and similarities between our two pictures. So for one thing, we know we're going to do a double bubble map. They both look the same, that's for sure. These are congruent images. They're the same size, same shape. So they're congruent. And they're also the same image. They're the same picture. We haven't changed the picture at all. But what's different about it? Well, our pre-image is facing right. The dog is looking to the right. And our image is facing left. So that's something that's different about the two. So one thing I want you to keep in mind, if we talk about properties of reflections, I want you to know that the pictures are congruent. Both pictures, whether it's the pre-image or the image, are the same size and the same shape. They're just flipped. So the picture is reversed or flipped. Right? It's just flipped the other way around. Oh, there's something else I want to show you. And this might look a little funny because my measurements might be off a little bit, but believe it or not, we're going to use this picture for a better example. And if I were to put a point on his nose, I'm going to call that A. That's point A. Now I'm going to put a dot, the exact same spot on the flipped image. I'm going to call that point A prime. I call it A prime with the capital letter A and a little apostrophe next to it. Now, if I were to measure the distance between point A and the line of reflection, it would be the same distance if I were to measure from A prime to the same dot on the line of reflection. Pretty cool, huh? I tried a better drawing on this one to try to prove my point to you. So in the dog's eye, I have point A on the pre-image. And on the image, I drew another dot in his eye. And that's A prime. I took my ruler and in centimeters, I measured the distance from A to the line of reflection, and I had about 3¼ centimeters. And then I measured the distance from A prime to a point, same point on the line of reflection, and I ended up with about the same, 3¼ centimeters. So the distance is the same from A to line of reflection and A prime line of reflection. And I can draw points as long as they match. I drew one at the end of the mouth here and B prime over here, and it's the same distance from the point to the line of reflection and B prime to the line of reflection. And you can do this with different dots all over it, and you'd find that as long as you measure from that point on the pre-image to the line of reflection, it'll be the same distance, or pretty close, from your other prime point to the line of reflection. So what I want you to take away from this, another property, points are the same distance to the line of reflection, as long as you're talking about the same one. For example, A and A prime. All right, that's all the time we have for today. We'll see you later.